ma'am. Now I request Subham Meena sir. Sir, please start the recording.
Started, sir.
Yeah, thank you, sir. So welcome to all and good morning and warm welcome to all the participants in the faculty development program on smart building design ECT for net zero, jointly organized by EI and ICT Academy with the Department of Architecture and Planning and Department of Mechanical Engineering at NIT Patna. And we are delighted to welcome our experts, Dr. Anjali Pathak, Assistant Professor in the Department of Architecture, VIT Mesra. She will be speaking on the thought-provoking topic on beyond four walls thermal comfort in slum housing, focusing on the often overlooked challenges of thermal comfort in informal urban settlements. And her insights will help us explore the interaction of architecture, climate responsiveness, and social equity in the housing designing. So now I call Dr. Subham Meena sir to briefly introduce the expert to the participants. Subham Meena sir, over to you, sir.
Thank you so much. And good morning, everyone. It is my great pleasure to introduce our next speaker, Anjali Pathak, Assistant Professor in Department of Architecture at VIT Mesra. Anjali Pathak is currently pursuing her PhD from IIT Roorkee and holds a postgraduate degree from SEPT University, Ahmedabad. With more than 8 years of academic and professional experience, her work has consistently focused on inclusive urban development, especially the challenges and spatial dynamics in informal settlement and housing for the urban poor. She has presented her research at several renowned institutional conferences, and her scholarly publication in peer-reviewed journal have added valued insights to the field of urban housing policy and social equity in built environment. In today's session, she will delivering a talk on Beyond Four Walls, thermal discomfort in slum housing, an important and timely topic that explores the interaction of thermal comfort, housing design, and urban informality in the context of climate responsive architecture. Please join me in warm welcoming architect Anjali Pathak. Over to you, sir.
Thank you, sir, for nicely introducing the session expert to the participants. And now we are delighted to have you with us, Dr. Anjali Pathak, and look forward and enriching an interaction session. Ma'am, over to you.
Thank you so much for your kind words. I'm still pursuing the PhD doctor's title will be in a year now. Thank you, though it is very kind words. So I would like to share the presentation and start the session without wasting a minute. Am I audible and able to share? My screen is visible?
Not yet, ma'am.
Okay. Now?
Yeah, now it's visible.
Okay, thank you. So, this presentation is basically about the slum or slum-like conditions where most of the population is concentrated. And we will talk about not just the thermal comfort, but about the discomfort also that people living in slum faces. So, cities now account for 75% of the global primary energy uses, and this number will increase with the urbanization, that is, with the current pace. Much of this rapid urbanization is occurring in the global cities of the developing world, enhancing the importance of urban energy efficiency for the world's long-term energy sustainability. And that is very obvious because we have the SDG goals also for the clean fuel energy. But why we are talking mostly about the slum is of importance to know that the Asian slum population is increasing and it is in absolute numbers. So the current dynamic shows that Asian slum population is 56.9%, which is more than the other other countries. And nearly 1 in 8 people in the world living in slum or the slum-like conditions. for Indian statisticals says that 55.4% of Indians are living in these urban slums, and heat stress is the prominent problem that is faced due to their infrastructure. So this is like temporary building material that they use to construct their housing, organically expand, and this organic expansion is haphazard. Lack of basic infrastructure services like road network, garbage collection, or you can say the water supply, the improved sanitation, and these are mostly residing in the residential or mixed land use area because they want to be close to their workplace or the livelihood. So they are concentrated on the prime land in the center of the cities usually. This whole thing comes under the physical capital. So I want to, though I have not mentioned here, but physical capital is among the five livelihood capital. Others are human capital that includes your health, employment, and education. Then the natural capital, the natural resources one have. Social capital that includes the social networking that people make with one another. And then is the financial capital that includes a financial like savings, the credit facilities people go with, and these are on the with the financial capital. So we are today concentrating on the physical capital that talks about the living condition of the slum dweller, and their tenureship. So slums are categorized by the poor quality of life. Davis in his work had even said that slums are the urban badlands, and because of the crime, the low living standard and everything had defined them as the urban badlands. And this is the lack of access of improved water sources, lack of access of improved sanitation facilities. Government had actually defined what are the improved and unimproved sources for the water or the sanitation, lack of sufficient living areas, lack of housing durabilities because of the temporary materials, and the lack of security of tenure. So, security of tenure is also Indian government notified, unnotified, and recognized. These are the three levels of tenure security. It is with the slums where they are residing. So these are the conditions that one can see that how they are living, and anywhere they are living actually, like slums or squatters. But within these slums housing, they are indulged in the livelihood activities. So they are making their resources uh, with all the available resources. They are earning and making it benefited for them. However, these are densely clustered and because of the choice of the material that they use to make their housing, like asbestos sheet, concrete sheet that we have, tin sheets, RCC, or the tarpaulin. Like in picture you can see that these are the different roofing that they have used for different materials. So, with the tightly clustered packed housing, they are actually polluted with dust, ash, smokes, and chemical. This may be because of their unhygienic conditions, or this can due to the home-based activities that they are indulged in. So home-based workers face the impact of indoor pollutants, and the most due to the great time spent in the indoor, and there is a lack of ventilation or the fresh air that they can utilize. So indoor temperature increases, and in one of the study later we can see that overcrowding is also one of the things that impacts the health of the dwellers living in the slums. So high indoor temperature led to increased demand for the electricity, and thus the fossil fuel requirement is also increasing for cooling or heating, and that is a financial burden on the people living in the slum areas. So increased cooling demand and reducing their income. This is directly proportionate to that. So slum in the city are 6 degrees warmer than their neighboring housing society. So this is the gap between the temperature of the two housing, and that is that not just say that the physical infrastructure disparity between the housing and the slums, but also the temperature at the indoor temperature at what they are residing and working also within the housing. Minimal scope of natural lighting, depend highly on the artificial lighting, because no cross ventilation, no natural light accessibility. So they are depending on the artificial lighting, and this increase their electricity bill, and this put them into the financial burden, hinders the residents' ability to reap economic benefit. Of course, when they are compacted, clustered, and overcrowded, they even minimize their livelihood activity space requirement also. So heat stress is a prominent factor for the home workers, especially living in the slum settlement, as it reduces the ability to work for the desired duration. People the Mahila Housing Trust, the NGO in Ahmedabad, worked on those slums in Ahmedabad and tried to figure out how much decline the production is when they are in these conditions. So they found that 50% productivity reduction in the summers, and among women are the prominent one to be indulged in the home-based activities. Moreover, every degree rises above 25 degrees Celsius, and there the result of 2% loss in the productivity of whatever the home-based activity they are carrying. So there comes a solution of cool roof solution and a better ventilation. Better ventilation is always difficult task to achieve because of the clustered and the compact housing. But cool roof solution facilitates the slums dwellers to at least being aware of the heat stress and how and strategize to minimize it. So heating resilient roofing technology are reducing the indoor temperatures and resulting in lower energy use and improving the health status of the resident living in the slums. So here in picture we can see that these workers are painting the asbestos sheet with white paint, and this coating is actually bring down the temperature inside the sanity at the slums in Ahmedabad. So further, the reduced energy expenses positively impact the economic status. So uh, in Kanpur also, when while doing my research work, I have seen that the financial burden, the most 80% of the slum are saying that summers are their worst month, and then among all the financial burden, electricity bill is quite high for them, and the slums are having metered connection. So by giving the when the notified slums have a metered connection, actually government is not only providing them the metered connection and the physical infrastructure availability and accessibility, but at the same time they are having a perceived tenure security also, that if government is doing something, providing an infrastructure, it's a perceived tenure security is also within them. So what makes them to do is they start making their housing better. So in this process, we have four interventions of the roof type. Roof type is actually um, major component that can reduce the heat stress. So four interventions were there: the solar reflective white paints that we have seen in the last image, modular roof, and air light ventilation. And the fourth one is the thermocol ceiling. So in the white paint is helping the house to be cool, And solar reflective paints are effect of external surface color on the thermal behavior of building, show that light color reflect the heat from the surface and help in the reducing the indoor temperature. On the other hand, solar reflective paints may have high solar reflectance and the thermal emittance. Following the literature, the roof of the household are painted on the top side of the paint is done on the top end, and before they were provided with white paint, women in this basti used to dampen the curtain inside to try to cool the surface. So alternative strategy, or you can say when the paint was not there, their coping strategy was to dampen the curtain and try to put it inside their house, and this is how they were coping the heat stress. Many a time they are not aware of the heat stress, and they have seen the health. So the modular now comes the modular roofing system. The second one. Modular roofing system is again the waterproof roofing made up of paper waste and coconut husk, signature product of the material. So we are reusing the material and making it a modular roofing system, which is environmental friendly and a good alternative for the RCC roofing system. It is also easily dismantled and can be taken to the next place where if they are moving to some place, or they can, if they want to dismantle it, reinstall it by adding the incremental housing or something, they can use it. So the roof proved to be boon for the slum dwellers with uncertain land tenures. Here is an important thing: when they move from one place to another, maybe their house get demolished and they are evicted. These roofings can be dismantled and can be taken easily to the next place. So this is giving them the advantages also: reduce the temperature of house and provide the eco-friendly alternatives. Now comes the third one, the air-light ventilation. Since slums are compact, clustered, haphazardly grown, so the excess of natural light is a problem. So air-light ventilation sheets are giving a passage to the daylight and airflow into the house, and often used in a household that do not have windows to for the fresh ventilation. And sheet is made up of fiber from the dome shaped structure that you can see in the second picture, with a small opening. So this ensures the circulation of the air while it's a transparent sheet, so accessibility of the natural light is also there. And household which install the air-light ventilation sheet usually express positive experience in the terms of using the artificial light or using the ceiling fans for cooling. Now comes the fourth one, the last one is the thermocol ceiling. The thermocol ceiling come from different kind of dropping roofs, like the false ceiling that we make. But the only thing is that here they are using the thermocols because it is cheap for them and can be removed and repaired easily. So affordability matters to them. And literature show that these roofs have thermal insulating qualities and improve the sustainability of reducing the expenditure on energy. So MHT Mahila Housing Trust have installed these four different kind of roofing system in different slums to help the slum dwellers to know about the heat stress and to cope with them. Unlike the conventional roof type that they are having, so let's have a brief also about the conventional type that they have other than the technological advanced version of it. So first one is a tin roof, then the asbestos sheets, and then the RCC concrete roofing. RCC concrete roofing is actually giving them a tenure security, a better version of the house, but then the heat is a lot more than with the cool roof system. So tin roof is a packet friendly and easy accessibility to them and widely used roofing system materials among the poor income communities, and lighter weight, flexibility, durability, reusability, and these are the structural characteristics that allow the slum dwellers to buy it and to use it. The Indian user probably identify this sheet as a tin sheet or the tin roof and absorb most heat and make the indoor hotter than the other roofing system. So these are the when although they are affordable, but they are making the indoor hotter than the other roofing system. Further, the chances of rust formation. So rust formation during the monsoons and corrosion. So they have to again rebuy it and then place the tin roof. Asbestos sheets are also the cement made up of cement as a base material, and these is a reinforced material to strengthen this sheet. Like the tin roof, asbestos is also the structural value that it when exposed to the weather and erosion. Unlike the tin roof, they provide better uh, facilities for roofing system, but are the source of airborne toxic fibers. And health researchers have reported that this type of roofing material could be the life-threatening diseases when people are living throughout their life and for the long durations. And then the RCC or the concrete one, so these roofs are generally categorized as Pakka house structure. The concrete is reinforced by the steel due to which they have tensile power. And then there are the preferred source of roofing system, but due to the tenureship is not clear, there is always a threat of eviction, whether notified, non-notified or recognized. They are trying not to make the permanent structure and try to eliminate the pakka structure with the other type of roofing materials. So modular roofing system and the control household from Vishwasnagar as a case study in Ahmedabad. The data show that the indoor ambient temperature start gradually rising by 10 a.m., reaches to peak around 12 p.m. and remain till 4 p.m. So when these temperature was taken, the indoor ambient temperature was taken. So for throughout the 24-hour duration, it was checking that at the 10, it starts with 10 a.m., reaches to peak, and then gradually decreases. But around from 12 to 4, there is a constant heat. So the ambient temperature of the modular roof is lesser than the other type of the conventional roof. And in the midday around 1 p.m. show that the ambient temperature of the modular roof is about 4.5 degrees Celsius less than the other conventional roof type. So here it is mentioned as a control roof. Further, the asbestos and the tin sheets are producing more heat, and the subgroup variations among the other two is less significant. So, and the air night ventilation heat up, the air night ventilation, which is giving them the privilege to have accessibility to the natural light and the air, heat up more than the non-interventional roof type. That is what we were saying to the controlled or conventional roof type. And it reaches 39.5 degree during the daytime, which is at least 3 degree higher than the tin or the asbestos sheets. Because of the accessibility of the light there, it increases the temperature. So the design of air light allow more light inside the house, but make the house warmer also than the other type of uh, non-interventional roof, or you can say the modular roof also. So hence air light may not be very effective solution to reduce the indoor heat stress, but allow the natural light where the artificial lighting is a financial burden to people. So this image shows that how four different type of intervened roof system reacts at different time duration. So at 10 a.m., 1 p.m. and 4 p.m. This is how the warmness or the heat stress can be measured, can be seen through images. In this, among the four cool roofs type, thermocol insulated is recorded the less one, the lowest surface temperature, whereas the airlight ventilation heat up and emit heat. And in the airlight figure, you can see that even the utensils are heated up, then the image is quite evident, making it evident that these are warmer. It is observable that over the period, utensils have been placed near the roof are also gradually heated, and this create an effect of similar to the heat island effect within the home. So indoor, it is increasing the heat stress. However, the slums sometimes or may not be based on their tenability status have a valid meter connection to access electricity. So these slums where the MHT Mahila Housing Trust has intervened and try to uh, change the roofing system, in these slums there was a metered connection to access the electricity, so they are paying for whatever the electricity they are consuming. The wall were built with cement and brick. Few houses had tiled flooring, or other than the cement flooring also. All the families have been cooking inside the house. This also increases the temperature, and using efficient LPG or the biogas as a fuel. So these are the improved cooking fuel energy. All the families have been using electric fans in their living rooms, and 50% of the house do not allow for cross ventilation due to the positioning of the doors and windows. And these doors and windows are usually open to the area of the street or to the next door, so the neighbor's door, when the respondent asked them for the favorable season. So winter was anonymously said to be the most comfortable. Then monsoon also trigger their home-based activities and recorded as a least comfortable season because of the unhygienic condition in which they are living. So this may be due to the structure of the household, poor drainage facilities that is there in the slums, and brings more discomfort during the monsoon in the form of inland flooding or waterlogging. These are the common things we can see in the neighborhood of the slum settlements. So further, most of the respondents reported that the electrical fan, air conditioning, air cooler, and sleeping outside the nighttime are effective measures to cope with the heat exposure. Throughout the day, they are working in the house, so engaged in the home-based activities, and then in the night as a coping mechanism to sleep, they are either using the electrical appliances or going outside in the nighttime for the sleep. So very few of them shared that wearing loose clothes helped them to protect themselves from extreme heat. As per the responses collected by the MHT, the heat-related illness affect 45% of the surveyed household during the summers. So the awareness, however, there was no awareness about the Ahmedabad heat action plan within the slum community. Two-thirds of the household were not aware that heat action plan is also in formulation, and it helps the knowledge from which can be used as a coping mechanism or the adaptive strategy as initiated by the Ahmedabad Municipal Corporation. So 60% of the respondents have never seen information, education, and communication about the heat action plan, and the material distributed to create the awareness was also not with them, which leads to the lack of understanding about the heat impact on the health, because they are using their coping strategy or the adaptive strategy as per their situation, not knowing the heat action plan in advance. So interestingly, in spite of having any access to the awareness material, 75% reported that they are aware of the rise in temperature. And this awareness is either due to the NGO's interventions, TV, or the print media. When asked for the effective primitive measures to combat heat stresses, they have reported tree plantation as an effective measure, because slum also don't have a recreational area, or you can say vegetated area where they can sit during the daytime, can have natural air, or can even start their home based activities also. So this is also a problem to them. From the summary of the Ahmedabad case, we can summarize that the slum or the informal settlements are mostly present on land with insecure land tenures. So there is no tenure security. They are with the threat of eviction. This caused the urban poor dwellers to lower access to government housing scheme, because they are unauthorized on the unauthorized land. So eviction can anytime happen. Further, the eviction threat another challenge in improving the house to the Pakka house by investing on their housing and making it pakka. This complexity, along with the poor economic status, forced the slum dwellers in to opt for household materials such as the temporary structures, which are pocket friendly, and in case of their eviction, they can dismantle and reuse it to the next place. Hence, technology like cool roof are the savior to them, because this intervened roofing system is also giving them the opportunity to dismantle and use it or reuse it in the same place. So thermocol, false ceiling, solar reflective paint, and mod roof are emerged as a promising solution to them. Unlike the airlight solution, because it is giving them natural ventilation and natural light, but it was heating the indoor environment to the great extent. So further, the airlight ventilation will lighten the house in the daytime, as we have discussed, but ultimately heat up the house. So this is not that so promising interventions. To understand the dynamics and the performance of cool roof, further studied on the large sample. Many products are not readily accepted by the slum community, owing to the perception that they are inferior than the mainstream solution. So, when if we are we if it is asked to us also that whether you will go for the RCC slab or the modular roof, one will definitely say that RCC slab if they can afford the RCC slab. Although modular roof will give them the much enriched benefit, but they will go for the mainstream solutions. So low income household aspires to improve their living and working environment to match the familiar standards that they perceive are the good ones. Impact on the health, illness during the last summers, knowing the heat action plan, seeing the information, education, and materials on the heat awareness, getting information about the temperature, awareness about the risk on the health. So these are the binary data collected on yes or no scale, to know that how many people are aware and how many people are not aware of the effect of the heat on their health, and if they are affected, then which medium help them the most. So now, unlike the western India, where temperature is a primary contributor to the heat stress, the effect of heat temperature in West Bengal, the eastern side, is exacerbated by the high humidity. So important factor involved are number of room, number of occupants, roofing material, wall material, presence or the absence of the windows, whether the windows are closed or open at night, and presence and absence of the frequent power failures, and the presence and absence of the electric fans. So like other slums in the West Bengal are also with the same situation of unhygienic, compact, overcrowded, unhygienic conditions. But the factor is that how they are adapting the excessive humidity. So the important factor associated with the high indoor heat uh, index is the electric failure, number of occupant related to the crowding index. So crowding index is people per room. So how many people are living in one room is derived. That is also sometimes synonymously used for overcrowding also. Suggests that body heat may contribute to indoor heat stress. And these are actually the factors that worsen the situation of the slums. Now, when slums are in under some policies or any interventions are redeveloped and provided with the public housing, then what are the condition of those public housing? So several policies have been put in place, eradicated to redevelop the informal settlement in the metropolitan cities. But this redevelopment or rehabilitation, like we see in Pradhan Mantri Awas Yojana, the first vertical say that to redevelop. So one such attempt was to tackle the slum formation in the Slum Rehabilitation Authority (SRA), which aims to redevelop the slum in the high-rise social housing. And this uh, winning point or the USP of the SRA had encouraged the government to adopt as a housing for all policy also. So increased density opened up land for market trade. So here it is done that all the slum dwellers who are the beneficiaries of the policy which is intervened in on that land are given public housing, or they are rehabilitated to the public housing, or they are sold to the dwellers there. The remaining land is open to the market rate, and this is a premium to the developer who are engaged in the redevelopment program. So success of the scheme led to housing for all policy with the same strategy of SRA. Now we are the Asian largest case, Dharavi, which is having home to 1 million people within the span of 535 acres. Historically, the Dharavi is unlike any other slum, is organically developed in the CBD of Mumbai. And given the magnitude of such redevelopment in Dharavi and rest of the world, energy and human comfort implications are enormous. Same situation that we have discussed from the previous slums-like conditions. So it is well known that building design decision impact thermal comfort and reduce building related energy uses. Moreover, recent research estimate that modification to urban form could reduce the energy uses by 26% worldwide. This redesigned building unit are potential spaces for thermal discomfort or loss of health if not taken seriously during the early stage design. So, as a part of Housing for All policy, state government and central government are encouraging the redevelopment of Dharavi in order to increase the population capacity, because they will go for the vertical expansion. And the redevelopment design are currently being made with respect to the spatial morphologies, community outlay, and building layout and material that had a significant long-term implication for energy demanding in the slum. So the built environment in Dharavi is currently categorized by, like other slums, have a deep, narrow alleys that lack access of sunlight and the fresh air. So the government plan to recluster them, the existing horizontal slums, into the vertical expansion. Important is the early design assessment of these one can say the housing they are providing signifies the thermal mass found in the dwelling walls should be increased to allow the nighttime cooling effect. So a feature that correlates with other work focused on assessing building parameters. Building morphology is the most sensitive parameter in the early design. When the schematic plans are made, that they can be discussed with the community, improving the community participation also, or one can say that participatory approach can be taken on the schematic design of the public housing. Thus a modified form required a careful design also. So window to wall ratio was found to be the most sensitive design parameter for thermal comfort, with 15% as a most desirable ratio. However, these thermal comfort guidelines are much more contextualized than utilizing the standard values. So they can be contextualized according to the place they are executed rather than having a standard and followed throughout the country at the same level. So this is again semi-localized contextualized thermal comfort guideline to the area of informal settlement. Redevelopment will be the foremost task. The significant body of research has utilized physics-based energy simulations as a basis for understanding how early design decisions impact the energy uses and comfort at the building and the urban scale. So the simulations are often based on deterministic inputs and modeling assumptions, which, if defined incorrectly, can leave lasting energy and thermal discomfort in the building. So factor including window to wall ratio, ventilation and wall insulations are among the most common parameters that affect building energy performance. And in slums, these all three parameters are made up of temporary material. So urban form and specified window to wall ratio had a substantial impact on stimulated energy uses and highlighted the potential for such results to provide guidance to the designers. The designers and engineers used the energy simulations tools in early design stages to understand how the building consumes energy and can provide the service to the occupants. So, hot and humid climate of Mumbai and differing cultural thermal response norms, low-income household rely more on ceiling fans and the natural ventilation than the other active cooling methods. So, National Building Code of India specify that indoor temperature ranges for all type of buildings, that is 21 to 23 degrees Celsius for winter month and 23 to 26 degrees Celsius for summer month. However, the study evaluating small and medium apartment identified that thermal comfort range for Indians should instead be between 26 to 32.5 degrees Celsius. So thermal adaptation measures by occupant action may be physiological, psychological, or behavior. And the thermal adaptation is region specific, and it should be contextualized according to the season and the climatic variation in the indoor conditions. Now, here is a plan of BSUP housing where we can see that how compact the residential units are made with two room set, and low income community living in public housing encounters similar issues of heat, light and ventilation, just like the slum-like condition they are living, because they are not the window to wall ratio is not taken care of, orientation of the building is not taken care of. So the facade which is on the southern side is extremely heated, and then they cannot use that space for their activities, home-based activities, and this reduce their production capabilities also. So housing layout, opening sizes, shading structures, and choice of material is not taken consideration while making the housing. So post-occupancy evaluation is also very important, where one can see that the housing provided to the slum dwellers is effective or not effective. By realizing that this is contextualized version can be can should cater the site specific requirement and then the seasonal variation on that particular location. So, moreover, residents belonging to economically weaker section often lack access to information on technology and products that can improve their overall thermal comfort. They remain unaware of extreme environmental change that hamper their livelihood. For instance, a study of slum community demonstrated the lack of access of information about the heat waves. Subsequently, they were limited opportunity to prepare for the extreme heat events and change in the behavior in anticipation. That is definitely broadcasted by the government for the public. So, Indian affordable housing domain have seen a national level push by the Pradhan Mantri Awas Yojana, and many cities in India are leveraging the national subsidies made available under the program. Units are either used to house resettled family or sold to eligible families at subsidized rate. We have already discussed that when the Pradhan Mantri Awas Yojana or under Pradhan Mantri Awas Yojana, the parcel of the land, the piece of the land is used for the social housing, and the remaining uh, parcel of the land is sold at the market price. So the subsidies can be managed by the government, and this is a premium to the developer also to develop social housing or public housing. However, there is a concern that there are not many takers of this unit if they are not comfortable and if they add to the family's electricity burden. So what, how about the facade which is throughout the day is heated due to their orientation of the building? So this will increase their electricity bill, and the indoor temperature substantially impact livelihood and the household activity. The study suggests that occupants preferred the temperature range between 26 to 30 in Ahmedabad, and respondents wanted a cooler environment and attributed their discomfort to the combination of high relative humidity or high temperature or low air velocity. So, common adaptive strategy, which was preferred choice for the respondent, include the ceiling fan. This making them dependent on the electricity, and respondent also preferred moving out of the house to sit in sunlight during the winter season. For so minimizing or cutting down the heating and then balancing their electricity bill. So this was observed even during summers when respondents go out and snap for the building terrace as a RCC wall radiated heat indoor during nighttime, causing discomfort. And since the occupants were relocated from slums, they were conditioned to extreme weather condition, and so they had lower comfort expectations when coming to the public housing because they are in the worst condition in the slums. So this result call attention to solution that are specific to context and residing communities, and there is a need to arrive at solution that is locally relevant to the challenges. So solar reflective paint on wall, like in the floor, they use thermal transmitted transmittance of roof. So solar reflective index, paint to the mosaic tiling is used, and sunshade of width 60 centimeter that guard them for the glazed sunlight entrance and bring in natural light and cross ventilation. Shaft are so from this presentation, what I have learned, and you will also, that the new research policy and regulations need to be simplified and maybe in a way that non-technical people can also understand, including the government, NGOs, citizen group, private developers, so that they can simplify and use it in their design process. Grassroots actors play an active role in extending the learning to the community and implementing and enabling implementation on the ground. And so what we have seen in the participatory approach, that schematic plans can be discussed with the public or the dwellers there. So solutions to tackle challenge arising from inadequate level of light, ventilation and thermal comfort among low income communities should be aspirational, and emergence of eco-friendly building products that are being targeted to low income communities with funding supports. However, many products are not readily accepted by the people also because of their the own perception of the standard products. So low income household aspires to improve their living and working environment to match the familiar standard or the perceived standard. That the product are sustainable and eco-friendly does not mean much to low income community unless they offer tangible benefit to them, justifying the higher cost. The mod roof adopted by more than 300 families in Ahmedabad is a testament to the willingness of the low income community to invest in the innovative product and enhancing their livelihood. So, an increased focus on building these units quickly and cost effectively is leading to the use of technology like monolithic concrete wall panels and other innovations that can help to reduce the heat gain. The ambitious target have sidelined thermal comfort within these units, which impacts the occupant health and work productivity of the family. The concrete panel wall used as a fast track solution to the construction, flexibility to the layout, providing timely, affordable housing options to the poor should not compromise their living standard. And when the mass production is there for the housing, they should be in a manner that increase the operational cost burden should be minimized. And thermal performance criteria of the public housing should be made priority. So this is all from my side. I'm open to take questions now.
Participants, if you have any query, please ask the experts.
May I come in? Hello.
Yes, sir. Reddy, sir, you are audible. Please ask your question.
Okay. I think Anjali Madam, it was a very good presentation from your end. It was really very the same because I have personally worked with the slums for the development projects and all that, and your in-depth analysis was really very. So it's a big eye opener. And I think you have repeatedly stressed on the two parameters which are very essential, or number one, which is the solid to void ratio in the entire, especially in the eastern India where there is humidity, as you have mentioned in the walls, the solid to void ratio, that is one parameter, number of rooms, number of inhabitants in the rooms, and accordingly. Now, I do not know whether if this is your area of research also in PhD or not. I am not much aware, but this is a very, uh, very intricate point today that where that so many renowned architects are actually working in the field, but don't see any of them talking about these parameters and these as passive, passive ways to mitigate the heat stress inside the building. So, uh, uh, can you suggest if there are any guidelines for this? I have not gone through any guidelines, but of course IGBC has certain guidelines. When you go for uh, that that is a certain thing, but our bylaws do not have any guidelines. Neither do any
Yes, sir.
have any benchmark.
Bylaws standards are not so available that people can just go through it or can be understand by the developers, and they are technical, but the guidelines I am also not very much into it, that because it's not my PhD topic. My PhD topic is for slums, but on just the livelihood part of that. So I had
I
taken a
understand.
break.
I understand that, and because whatever guidelines I have come across in my 25 years of experience is that these guidelines never speak of uh, the solid is to void ratio, that is minimum, or what can be maximum, or whatever it. So
So
and
somewhere,
there
so in
are
some paper, I have seen that 60% can be maximized and 15% is like desirable to them.
yes, and that's what you have found out.
Yes.
Yes, I think yes. So that is why I don't have a question directly, but I just wanted to know, since you are doing an in-depth PhD in this area, have you crossed any such guidelines or
No,
any
sir, not
standards
yet.
or guidelines?
No,
Thank
sir,
you,
no. I
thank
have
you, and
not
it was
come
a
across
really very good presentation. Thank you so much.
it.
Hello.
Yes.
Ma'am, what is the solution for daylighting in slums without compromising this thermal comfort? Like any techniques you have
So
implemented?
one such solution the Mahila Housing Trust tried to intervene is by the air light roofing system. But the problem is that heat is more than the other intervened way. So that was the only solution I have come across for the with air light for the accessibility to the natural light and the air.
And
Otherwise, they have intervened in the public housing.
what about the air ventilation without compromising thermal comfort?
And so, like I've told, that air light roofing system is the only solution uh, that has been tried to slum areas, but then the heating is a problem there because of the access of accessibility to the natural light.
Like any guidelines you have referred regarding the window to wall
No, I have
ratio?
not reviewed the guideline. I have gone through the case studies of different slums and the interventions taken there.
Okay. So this you said 10-15% window to wall ratio is enough for ventilation
That is
and
a minimum
heating.
written by the researchers and their in their contributing work, that this is what they are likely to take.
And what about the uh, sciography or open space next to this window to wall ratio open uh,
So,
fenestrations?
in the last image, perhaps I have shown that the sunshade should be at least of 60 centimeter width, so that the sunlight glazing can be avoided, and then can be no direct accessibility to the sunlight. So this is how they are trying with a um, minimum intervention or increasing their finances. Most important is that anything you are doing will be burden on the slum community. Either they are the beneficiaries, direct beneficiaries, or they are purchasing the public housing. So minimum interventions orientations can help to reduce the construction cost.
This fenestration basing on the site topography, like next to the trees or next to the building shadows, will it help in the thermal comfort?
Yes, definitely thermal comfort may it will help, and people are moving out during the daytime even if there is a vegetation or the tree is there, so they start working there. And in my research also I have seen open spaces in the slum where the plantation is there, people work there. So so for basket making or in Kanpur, we see leather work products are made. So this is the common view in the slums, where home-based activities are not in the home. They even move out if the climatic condition or the environment benefits them.
So my question is, this fenestration with the adjacent topography, either it is building or tree, with that topography or shadows, without those pyrography or this shadows, what is the thermal difference?
I can't say this number because I have not researched in this. I'm really sorry.
Okay, thank you.
Thank you.
Participants, if anyone have any query. Ma'am, I just want to know just a little discussion. As per your experience, in terms of construction cost, keep in mind construction cost, you saw the number of different just white paint and mud houses and different. So to improving the thermal comfort, which strategy is implemented? We are going slum area, we are going for thermal houses, yeah, paint, yeah, other than.
So, in Ahmedabad, we have seen that NGO had intervened with the slum community to persuade them that they can go for intervened roofing style, and they're the but the most common one in Kanpur slums also I have seen that they go for paint, solar reflective paints, because because painting costs them lesser than the changing the roof style. So this is how they are getting the knowledge from the other communities and implementing it.
So means painting is that technique, but you get maximum thermal comfort with minimum cost.
Minimum cost, because you are not purchasing purchasing to the higher cost also.
Yeah, in terms of thermal slum areas, keep in mind that one is good strategy
That
in
is
realistic
yes.
approach. Thank you for my side. Participants, if anyone have any query, otherwise we are going to conclude the session and end the session. If anyone has any question, please write in the chat box. So I think question session is over. So let me opportunity to conclude the session. So thank you all for joining the session. That is session engaging on the beyond four walls thermal comfort in slum housing, delivered by architect Anjali Pathak ma'am. And the session is offered a valuable insights into the challenges of achieving thermal comfort in informal housing. And the ma'am is also highlighted the social environmental factors affecting slum dwellers and emphasizes the need for climate responsive designs in understand the urban communities. And she also shared a compelling case studies that illustrated the real world thermal comfort issues and potential passive designs interventions in slum settlements. So we sincerely thanks Pathak ma'am for her wonderful thoughts and impactful presentation. And
Thank you so much for giving me the opportunity, sir.
thank you, ma'am. And we look forward for your continued participations and for in the sessions and in future, ma'am. So
Thank you.
participants, we now meet in the next session at evening 4 o'clock. So thank you everyone. And with this, we close the session.
Thank you so much, sir.
Welcome.